This video is meant to be an overall review of some of the most commonly tested questions on your Algebra 1 state test. So I do have some individual videos that you can see on each topic. This is meant to be an overall review to perhaps watch the weekend before your test. So let's get started. First, I want to go over the calculator you can use on the state test. It's in my Google Classroom under a post called Use This, Not Your Phone. Please practice using this calculator. When you click on the link, you're going to see it's a modified version of Desmos. And if you scroll down, you're going to see an option to click to show the keypad. This is what the keypad is going to look like. This calculator can graph equations and functions, but it can also make simple calculations. So for example, I want to make sure you know if you want to enter something with a square, like if I had 5 squared, then I would click 5 and then this button. If you wanted to enter something with a different exponent, then you would use the button right next to it instead. So if I wanted to write 8 to the negative third power, I would do 8, then click this button to the negative third power, and it would tell me the answer. Another important button to use is the square root button. It's right here. And if you have a square root with a number on the outside here, then you're going to have to click on Functions to see some other options. If you go to the Miscellaneous tab, you're going to see it right here. If you click that button, it's going to give you a space to put a number here, and you could put whatever number underneath the root. One other thing I would say about this calculator, if you ever have a fraction, let's say you had 5 to the third minus 2 over 4. When you put this in your calculator, you can enter a fraction bar with the division symbol. But when you have more than one thing in the numerator, you want to cup this whole thing in parentheses. So you would do parentheses, 5 to the third minus 2, end parentheses, and then this for your fraction bar. And then enter your 4. And it will say what that equals. Now let's talk about equivalent expressions. If you're given a question like this and they want you to write an equivalent expression, you're just distributing, combining like terms. A few clues I would give you, a few hints, common mistakes that have been made. People have messed up with fractions. They've lost some negative signs. And also when you're distributing, make sure if you're multiplying a variable times a variable, that you add an exponent. So if you're doing x times x, then your answer is x squared. So if I wanted to distribute this, what I might first do is change 2/5 to a fraction by taking 2 divided by 5. And when I put that in the calculator, I would get negative 0.4. So I would just rewrite this. And you want to make sure you are using your scrap paper. Don't just do this in your head. You want to be extra careful not to make any small arithmetic mistake. So I would write this down and then I would draw myself the arrow and say in my head, negative 0.4 times 6, and put that in my calculator. Negative 0.4 times 6 is negative 2.4, but this is negative 0.4 times 6p. So it would be negative 2.4p. And then negative 0.4 times positive 10. Make sure you're keeping mind of whether these numbers are positive or negative. And this would be negative 4. And then you have your minus 18. After you distribute, then you identify the like terms. Remember, like terms have the same variable and exponent. So there's no other terms that have a p in it, but there are two just constants, negative 4 and negative 18. When I combine those, I get negative 22. So it would be negative 2.4p minus 22. It's okay to give your answers as a decimal or a fraction. If you are giving your answer as a fraction, make sure you simplify. This is an example of a state test question, or one very similar to that. There's a lot of parentheses here. This first set of parentheses really isn't necessary. There's nothing on the outside. It's just saying 3 plus y. But here on the left, there is a set of parentheses, and we're saying 4y times 5y plus 2. So we need to distribute that. When I distribute 4y times 5y, that is saying 4 times y times 5 times y. If I multiply the 4 times the 5, I get 20. And what's y times y? It's not y, it's y to the second power. And then 4y times negative 2 would be negative 8y. So I'm multiplying the 4 times the negative 2, and then I'm putting the exponent on there. And then I still have my 3 plus y. And is this 20y squared positive or negative? It's positive, so I'm going to put a plus there. After you distribute, you just combine your like terms. Remember, like terms have the same variables and exponents. So this one has a 2. There's no others with a y squared, so I'm going to leave that as 20y squared. But there are 2 that just have a y. 1y minus 8y is negative 7y's. And then I have a positive 3, so I'll put plus 3. Now let's talk about solving equations. When you're solving an equation, there's 2 different ways you can do it. First off, you can solve it by hand. I'm going to show you here in a moment how you can check your answers or get your original answer on the state test using that graphing calculator. But first, let's just solve this by hand. I'm going to write this out on my scrap paper during the test. You always first want to distribute before you move anything around. So 12 times x, and then 12 times positive 5. So distribute, and then you want to move it so all the variables are on one side. Since my right side only has something with the variable, I'm going to move that 12x over there. So I'm going to move that 12x over to the other side by subtracting 12x. Because 12x minus 12x makes that go away on the left side, and I need to subtract 12x on the right side as well. So I'm left with 60 equals negative 8x. I'm doing 4 minus 12. Now I'm going to undo that multiplying by negative 8 by dividing by negative 8. And when you do that, that cancels out and you get x equals negative 7.5. Now I'm going to show you how you can get the same thing on a graphing calculator. So on the state test, you can solve it in this way because you'll always have access to the graphing calculator. You just move everything over to one side, so that 4x I'm going to move over to the left side by subtracting 4x. So I need to do that on both sides of the equal sign because this cancels out and I'm left with a 0. And on the left, I have 12 x plus 5 minus 4x. And then the last step is to change that 0 to a y. This is what I'm going to enter into my graphing calculator. Notice I'm not going to distribute, I'm not going to combine like terms. I'm just going to take everything, move it over to one side by doing the opposite operation, and then graph it. And when you graph it, this is what you're going to see. You want to click on the point where the graph intersects the x-axis, and that is your answer. Answer is whatever the x-coordinate is. X equals negative 7.5. The same answer we got when we solved it going through the steps. Let's do one more like this. So I'm going to first solve this one by hand, so I'm going to write this down. Remember, always write this down on paper and go through the steps. I would prefer to get rid of that fraction. I can do that by multiplying every single thing by 4, or I can change that fraction to a decimal by taking 3 divided by 4. And 3 divided by 4 is 0.75, and then I'm going to leave everything else the same. Now, there's nothing I can distribute, no parentheses, so now I'm just going to collect all my variables on one side. So I'm going to move my negative 3x to the left side by adding 3x to both sides, because minus 3x plus 3x is 0. When you look at the left side, we now have a 2x plus 0.75 plus 3x. I'm going to combine the like terms. 2x plus 3x is 5x, and then I still have the 0.75. Now I'm going to move things away from my variable. So I'm going to undo this plus 0.75 by subtracting 0.75 from both sides. And then I'm going to undo the multiplying by 5 by dividing by 5. And I'll see that x equals 1.85. Now on the state test, you could substitute this back into your original equation for x and check your answer. Make sure that what you get over here equals the same as what you get on the right side, or you can solve it by graphing like this. Remember, to solve this by graphing, you're just moving everything over to one side. So I'm going to move that plus or that minus 3x to the other side by adding 3x to both sides. Remember, using this method, I'm not even going to worry about combining like terms or anything. I'm just going to leave the left side as 2x plus 3/4 plus 3x. That way there's less room to make any sort of arithmetic mistake. Now I'm going to move that 10 by subtracting 10 from both sides. So now I have a 0 on one side, which is what I wanted, and then the 2x plus 3/4 plus 3x minus 10. It looks like a mess, but again, there's less room to make any sort of mathematical mistake, and I'm just going to enter this into my calculator after I change that 0 to a y. And when you do, again, the answer is where it crosses the x-axis. So just like when we solve this by going through our steps of isolating that variable, we get the same answer, x equals 1.85. Now I'm going to show you how to solve quadratic equations using the same method. You can solve quadratic equations by factoring, by using the quadratic formula. On the state test, since you have access to the graphing calculator, I would recommend you solve it by graphing. So this is the same deal, except there's two answers. Our graph is going to cross the x-axis in two places. So I'm going to move all my variables to one side. So I'm going to move that plus 5 to the other side by subtracting 5, because that's going to cancel. And again, I'm just going to write everything as it is. Not going to worry about combining any like terms. You can if you want, but you don't have to. Oops, it's not 25, it's 27 minus 5. And now I'm going to move that minus 6x by adding 6x to both sides. And when you do, minus 6x plus 6x is 0. So we're left with this. We need to have an x and a y to put it on the state test calculator. So I'm going to change that 0 now to a y. So we are looking for, what does x equal when y is 0? We're looking for that x-intercept. So let's graph it. When you graph it, you're going to be able to click on the points where the graph intersects the x-axis. It's important now that you are interpreting this. You are not putting the point -2, 0. We found out that when you put 0 in for y, x is -2. When you put 0 in for y, x is 1. So those are our two answers. Now let's talk about literal equations. These are equations that have a lot of variables. We're solving them in the same way. We can't solve them on a graphing calculator, but we are moving things from one side of the equation to the other by doing the opposite operation. So if you have something like this and you want to solve for W, then we look and say, well, what's happening to W? What's keeping W from being by itself? Well, W is smushed up against H, so that means it is being multiplied by H. So if I want to undo the multiplying by H, I'm going to divide by H, because H divided by H cancels out, and I'm left with W on the right side. Whatever you do on one side of the equation, you have to do on the other. So this, I have to divide by H as well. Now, I don't know what M is, and I don't know what H is. Those are unknown numbers, so I don't know what they are. I can't divide them, and they're not like terms. So I just leave it as M divided by H. So your answers here are a lot messier because you can't combine like terms. This is another way a literal equation question might be worded. It's giving you a question saying create an equivalent equation by solving for x in terms of y and c. If you're confused by the wording, just notice that there is an equation here that has a lot of different variables, a lot of letters, and notice what letter are they solving for? X. So let's write our equation down, and we want to solve for x. Ask yourself what's happening to x that's keeping it from being by itself. It's being multiplied by 3, and we're adding c. I always undo what's added or subtracted first, so if we want to undo something that is added, we do the opposite of adding, which is subtracting. And you have to do that to both sides. Because c minus c, any number minus itself, cancels out. And on the left, we don't know what y is, we don't know what c is. They're not like terms because they're not the same variable, so we have to leave it as y minus c. Now, if we want to solve for x, it's being multiplied by 3. So we undo that multiplying by 3 by dividing by 3. Because anything divided by itself is 1. What you do on one side, you have to do on the other side as well. So the answer is y minus c, all of that divided by 3. A common type of question with these literal equations on the state test, they're going to throw in a square or a square root. So you need to remember to undo squaring, the opposite of squaring is square root. The opposite of square root is squaring. So for this one, they're giving us an equation and they want us to solve for c. So what's happening to c? It's being squared and it's being multiplied by m. You undo the squaring last. Let's first undo this multiplying by m. What's the opposite of multiplying by m? Dividing by m. Because anything divided by itself is 1. So we have to do that on both sides. Now we can undo the square, so c would be by itself. How do we undo squaring? The opposite of squaring is square root. So you take the square root to undo the square, and then c will be by itself. And you have to square root that entire left side. So we would be left with the square root of e divided by m. The last thing I'm going to say about literal equations is it might not be written so clearly as this. There might be a paragraph explaining the equation and telling you what E stands for and M stands for and C stands for. If you notice that there is an equation with a bunch of variables, know it's one of those literal equation questions, and they just want you to move things to the other side and solve for one of those variables. Now let's talk about functions and evaluating functions. This is really just about substituting in and putting it in your calculator on the state test. You need to know that this is a function here. This is not read f times x equals 2 times x minus 8. When you see this function notation you see in green, you want to read this as the function is 2x minus 8, okay? And instead of f, they could use a G or an H, but if there's a number written in kind of that cursive next to an x in parentheses, that is the function notation. Read, the function is... Now this I would read as the function is 2x minus 8. They want us to find out what is the answer if you put 3 inside of the function. They want us to put 3 inside the function. I'm sorry, I just realized that I wasn't recording. I don't know how far back I wasn't recording, so I'm just going to start here. I apologize if I'm repeating myself. So interpreting graphs, if you are given a function that represents a situation, you can graph it and then look at that graph and interpret what is happening, what that function is telling you. So here it says a grasshopper jumps off a tree stump. The height in feet of the grasshopper above ground after X seconds is modeled by this function. So first you want to identify what does the X and the f of X represent. And it says the height in feet is modeled by the function. So f of X is calculating the height in feet. And it says X is the seconds. So I would write that down on my paper. X equals seconds. F of X or Y equals the height. Then graph it. When you graph it, you might not initially see the entire graph for these real-world problems. Sometimes you might need to zoom in or out. Once you see it, you want to click on the key points of the graph. And you want to sketch this on your paper so that you can label your x-axis and your y-axis. Remember, the x represents the seconds, the y represents the height. So when you graph it, ask yourself, can the x be negative? Can seconds be negative? No. Can my height be negative? No. So we don't care about this part of the graph when the height is negative. And we don't care about this part of the graph when the seconds, the time is negative. So I would just draw what's in the first quadrant on my paper. After you sketch it, you want to label your x-axis, remember, is your seconds, and your y-axis is your height. Now, an important step is reading each of these points with the labels. So this point right here, x is seconds, y is height. So at 0 seconds, the height is 1.25. At 1 second, the height is 2.25. And at 2.5 seconds, the height is 0. So at what height was the tree stump was a tree stump that the grasshopper jumped off? So another important thing is this is asking for the height. So they're asking for my y coordinate. So I might write that down. So at what height was the grasshopper? At time 0, right before it jumped. That would be this point right here. And the height is 1.25. What is the maximum height? Again, they're asking for my y coordinate that the grasshopper jumped. What is the biggest y coordinate we see here? The peak. That would be this point right here. And they're asking for the height, and it would be 2.25. If it asked me, and that's what they're doing in step C, after how many seconds, that's my x coordinate, did the grasshopper land on the ground? So it landed, so its height is 0 inches off the ground. It would be this one. And it's asking me for seconds, so it would be my x coordinate. So again, some key points with this. You want to identify in the problem, what does x represent? What does y represent? You want to graph it. You want to sketch this on your paper, read the key points with the labels, in this case seconds and inches and height. And then when you're answering the question, make sure that you are giving the correct part of the coordinate. You might realize that this is the coordinate that is giving the maximum height. But are they asking for the height, or are they asking how many seconds did it take them to reach that maximum height? So make sure you're very clear about whether it's asking for the x coordinate or the y coordinate. Now let's talk about sequences. This is a sequence. You've done this since elementary school, probably. You're able to identify what the next number is in the sequence pretty easily. What we're doing in Algebra 1 is creating an equation or function to represent this sequence. And before you do that, you need to know that you are being given the first term, the second term, the third term, the fourth term. We are going to refer to these terms as when x is 1 or when the number is 1. The second term is when x is 2 in our equation, or when the number is 2. Okay? So when we substitute 1 into the equation for this function, for this sequence, then we should get 3. When we substitute 2 into the equation for this sequence, we need to get 5. So you might be presented with a question like this, where they're giving you a sequence and they're giving you these different functions and asking which of these functions will create this sequence. So you could completely ignore the sequence from the beginning. And then we can look and see what the sequences are for these 4 choices. And then look at the sequence and see which one matches. So what I mean by that is what we're going to do is substitute 1. If we look at this first choice, let's substitute 1 in for x. So it's 1 minus 6. And we get negative 5. So that means the first number in the sequence is negative 5. Now let's substitute 2 in for x. So we get 2 minus 6, which is negative 4. So the second number in the sequence is negative 4. And then let's substitute 3 in for x. So 3 minus 6 is negative 3. So my third number in the sequence is negative 3. So we can look at our sequence now and say, is the answer A? No, negative 5, negative 4, negative 3. That is not what the first 3 terms are in this sequence. So we know the answer is not A. Let's skip down to C. If we put 1 into this equation, 5 times 1 minus 6 is negative 1. So our first number is negative 1 in this sequence. Now let's put 2. 5 times 2 minus 6 is 4. So 4 is my second number. Then let's put 3. 5 times 3 minus 6 is 9. So now let's look at our sequence. The first number matches, they're both -1, but the second term is not 4. The third term is not 9. If you were a little lazy and just did the first term, you would think the answer is C because it gives you -1. I'm showing this so you see the importance of checking at least 3 of the terms. So let's look at D. So if we check this one, we do get the -1, -7, -13. So D, this equation, this function, will create this sequence. So again, the important thing to remember is to check all of your choices and make sure that you're looking to check at least 3 of the terms to find the one that matches. It has to work for all of the terms. We're not going to solve this one, but I want to show you how this is a similar problem, except instead of x, they're using n. So substitute 1 in for n and see if it gives you 2.5. Substitute in 2 for n and see if it gives you 5, and so on. This is another way you might be presented with this sort of question. They're not giving us the entire sequence, but they are telling us that the third term is 10. So you can substitute 3 in for n and see if it gives you 10. And then they're telling you the fifth term is 26. So substitute 5 in for n and see if it also gives you 26. You're looking for which of these functions gives you both a 10 when you put in a 3 and a 26 when you put in a 5. This is another way you might be presented with a sequence problem. So they're showing you a sequence and they're showing you the terms, not all of them, but in a table. So for me, I would first write these out the way I typically see sequences. So I don't know the first term, but I know the second term is an 8. I don't know the third term, but I know the fourth term is a 17. I don't know the fifth term or the sixth term, but I know the seventh term is a 30.5. So I am trying to find out what is the first term. That's what this is saying. So if we assume that this is that we're adding the same number over and over, it's an arithmetic sequence, then we are adding some number to get this, and we're adding the same number to get this. So what is the difference between 8 and 17? We get, what, 9? So if we are adding 9 to get from here to here, what if we divide that in half? What number do we add twice? That equals 9. 4.5, because 9 divided by 2, divided in half, is 4.5. So let's test that out. If we add 4.5 to 8, what do we get? And if we add 4.5 to 12.5, do we get 17? Yes. If we add 4.5 to 17, we get 21.5. And if we add 4.5 again, we get 26. And if we add 4.5 again, do we get 30.5? Yes. So what's happening each time is we're adding 4.5. Now, is the answer here 4.5? No, it's not asking us what we're adding each time. It's asking us what the first term is. So what number plus 4.5 gives you 8? What number plus 4.5 gives you 8? Well, if you subtract 4.5 from both sides, you see the answer is 3.5. If this is 3.5, 3.5 plus 4.5 is 8. Now, one other type of sequence problem you might be given is if they give you a sequence and they say, what is the 100th term in this sequence? Now, I can see that I'm adding 2 each time, but let's think about what's happening here. if you know the first term, I'll tell you, if you know the first term and you know what we're adding each time, then you can find the 100th term easy by noticing this relationship. If you take the first term and you add that common difference one time, it'll give you that second term of 5. If I take the first term and I add that common difference 2 times, it'll give me my third term. If I add it 3 times, it'll give me my 4th term. So if I want to find the 100th term, do you notice the relationship? 4. I'm going to take the first term and I'm going to add that common difference 1 less than the number term I'm trying to find. So you're always taking the first term and you're adding the common difference 1 less time than the number you're trying to find. So if you give me a sequence like this one, you just need to know, well, what's the first term and what's the common difference? Just pick 2 of the positive numbers, the easier numbers. I'm adding 7, right? I'm adding 7. So I'm going to add 7 how many times? Well, to find the 75th term, I'm going to add 7 74 times. Now that's the same as 7 times 74. So I would just put this in my calculator. When you're taking the state test, if you don't remember this process, come up with a little example, an easy sequence like I did, the 3, 5, 7, 9, and go through and try to figure out the relationship. How many times are you adding that common difference to the first term to get the 4th number in the sequence? Another type of question you might see is solutions to linear equations or functions. So it's important to know that if you were to graph an equation that has an x and a y, all of the points on that line represent solutions to that equation. So if you were given a question like this and they're asking which of these points is a solution to that equation, then you can graph the equation and then graph each of the points and see which of the points is on the line. So here, if I graph the equation and then just click that plus button and add each coordinate inside parentheses, it will plot them. You'll see only one of them is on the equation, on the line, and that is our purple dot. So the answer would be 6, 11. The other way you can do it by hand is just looking at one of the options at a time and substituting them in and seeing if it's true. Is 1/2 times 4 plus 8 equal to 5? If not, substitute in the next x and y coordinate. Is 1/2 times 2 plus 8 equal to 10? If not, look at the next choice. This is another type of question you might be presented that's really getting at, do you understand that for an equation, the coordinates represent solutions to that equation? So if you put a 5 in for x, what does y have to equal? So that when you multiply the x coordinate by 5 and subtract 4 times the y coordinate, the answer is 18. So you're just substituting in. So write that equation, but instead of x, put 5 and then solve. So I'm going to multiply 3 times 5, and I get 15 minus 4y equals 18. Now I'm going to move the 15 over to the right side to get the y by itself. So I'm going to subtract 15 from both sides. And then I'm going to undo this. This is not subtraction. This is -4 times y. So I'm going to divide by -4. And divide this by -4 as well. So you end up with y equals -3/4. Now let's talk about scatter plots and correlation, specifically the correlation coefficient. So a scatter plot looks like this. Each piece of data is represented by a point. You're looking at two variables to see if there's a relationship, to see if they are correlated. If the dots are all scattered about like this, you say there is no correlation. The correlation coefficient equals 0. Now, if it's positive, the correlation coefficient is between 0, where there's no correlation, and 1. So this is weak, and the closer it gets to 1, the stronger it gets. Now, if it's weak, then the points are going to be more scattered. Now, since it's positive correlation, it's going to be going up from left to right. It has a positive slope. So it might look like this. Notice it's going up from left to right. This might be our line of best fit, but the points are scattered. So this has a weak correlation. It might be something like positive 0.23. Now, if it's strong, the points are going to be closer to that line of best fit. And so it would be positive because it's going up, and stronger, so it's closer to 1. So it might be 0.89. Now, a negative correlation has a negative slope. A negative correlation is 0 when there's no correlation, all the way to -1, and that is stronger. So the closer it gets to -1, the stronger it is. The closer it is to 0, the weaker it is. So if it's weak and negative, the dots are going to be more scattered about, but still going down. If I were to draw a line of best fit, from left to right, it's going down. So a weak correlation that's negative would be -0.14. Where if it's strong, the points are going to be closer to that line of best fit. Again, it's strong, but it's still negative. So it would be negative, closer to -1, because it's not weak. Weak is closer to 0, so it could be -0.79. So here, at 0, no correlation. That's when it's weakest, and then it's getting stronger as it moves to +1 or -1. So this is a question you might be presented with. They're showing us 4 different scatter plots. They want to know which scatter plot has a correlation coefficient of -0.9382. So you need to ask yourself, negative, that means negative slope. That means it's going to be going down the line of best fit. And is this strong or weak? It's closer to -1, so the points are going to be closer to that line of best fit. So for this one, what would the answer be? This one right here. Here's another correlation coefficient question. They want to know which of these has weak correlation. You want to make sure you don't assume negative means weak. Remember, weak is closer to 0. 0 is no correlation. So the closer it is to 0, the weaker it is. So which ones of these are weak? This one and this one. Now let's talk about systems of equations on the state test. These are easy questions because you can use the graphing calculator on the state test. So all you need to do, if the equations don't use x and y, if they use other letters as variables, change the equations to x and y, graph both equations, and the solution is where the lines intersect. Remember, the graph of a line includes all the points that represent solutions to that equation. So you're just looking for the point that is on both of the lines. That is a solution to both of those equations. So if I'm asked to find the solution to this set of equations on the state test, I just go to my graphing calculator, I graph each one, and then I click on the dot where the blue line intersects the red line, and that's the solution. Here, I'm given this system of equations. Notice one of those equations has an x squared in it. Same process though. You want to go to the graphing calculator, graph both equations. In this case, they intersect at 2 points, so there's 2 solutions. It's just asking for one, so you just pick either one. Here, they're giving you 2 equations with an x and a y, and it's a word problem. So you're going to enter this into your calculator, but you first want to ask yourself, what does the x represent? What does the y represent? So look to the problem, to the explanation, and you'll see that x represents the bag of chips, and y represents the x represents barbecue chips, and the y represents regular chips. So I would write down x is the barbecue and y is the regular. Now, what are they asking me for? They're asking me how many bags of barbecue chips. So they want to know just what the x is for that point where they intersect. So if you enter them into your calculator, you'll see this. Remember, there's lots of different points. We have some x-intercepts and y-intercepts. We care about what point is on the red line that is also on the blue line. So we're looking at that point 8, 12. Once you identify the point, you want to look to the question again. Are they asking for the x-coordinate or the y-coordinate? And in this case, they're asking for barbecue chips, which is the x-coordinate. Some people might get the point right, 8, 12, but if you answer 12, you're going to be marked wrong. Here's another type of problem where they're giving us both of the equations, which is nice, but if you were to try to graph them, you'll notice the graphing calculator won't do it. It doesn't know what G and S are. So what you need to do first is write down what G represents and what S represents. So on my scrap piece of paper, I would write down the original equations, and I would say G is the number of general admission tickets, S is the number of student tickets. And now I'm going to change these equations. Instead of G, I'm going to use X. Instead of S, I'm going to use Y. So I'm going to write those down, and I am going to be extra careful to write down now, what does the X represent? What does the Y represent? That way, when you graph it, you'll know, am I giving the X coordinate or the Y coordinate? This is what you'll see when you graph these 2 equations. What is the answer? Is it 126 or is it 99? It's asking how many students, which is the Y coordinate, so I would answer 99. You might be given a problem where you're asked to write an equation or write a function or write a system of equations. For all of these, it's important to read the problem, imagine yourself there, imagine you paying for these tickets, you gathering these money. First, identify what the variables are and write that down. The variables are what you do not know. So in this case, we have adult tickets for a school musical. They sold for $350. Student tickets sold for $250. On one night, 321 total tickets were sold for $937.50. How many of each kind of ticket were sold? So those are our variables. We don't know how many adult tickets were sold. We don't know how many student tickets were sold. So we need to pick one of them to be X and one to be Y. When you have more than one variable, when you have 2 variables, you have to have 2 equations. The biggest thing I would tell you about these equations, especially when you're given a lot of different numbers, is to make sure the labels are the same on both sides of the equation. So money plus money equals total money. Tickets plus tickets equals total tickets. You see what I mean? So here, you're gathering some money for the adult tickets. Adult tickets cost $3.50. So how much money are you getting for the adult tickets? Are you getting $3.50? Well, if you only sold one adult ticket, but what if you sold 5? You would get $3.50 times 5. So you're taking $3.50 and you're multiplying it by the number of adult tickets that you sold. And then the student tickets, they're $2.50. But you don't just get $2.50, you get $2.50 times however many student tickets you sold. So these two things added together, does that equal 321? No. Money plus money equals total money, right here. Now we need to come up with another equation. Tickets plus tickets equals total tickets. So how many total tickets were sold? 321. How many adult tickets were sold? We don't know. Remember, that's our X. How many student tickets? We don't know. That's our Y. So this would be our second equation. Once you have your equations, you put them in the graphing calculator and see where they intersect. When I put these in my graphing calculator, this is what I see, which is confusing. It doesn't work. What do you do? Notice that the numbers that we're using here are pretty big. So what we need to do is zoom out. And then again, click on those key points. Which of these numbers is giving me the solution? Remember, we don't care about our x-intercepts, y-intercepts. We care about the point where they intersect. So for this one, is our answer 135 or 186? Well, they're asking for the number of adult tickets. It's so important that you write down what X is and Y is. It's asking for our X coordinate, so it would be 135. Two more topics. Multiplying binomials. This is using the FOIL method. So if you're given a question like this, you want to write it down on your paper. They just want us to multiply it. Right now, this is saying 2x plus 8 times 5x minus 7. Write it down on your paper and use the FOIL method. So what that means is you multiply the first numbers in each set of parentheses. So the 2x times the 5x. 2 times 5 is 10. X times x is not x, it's x squared. Then we multiply the outside numbers. 2x times negative 7 is negative 14x. Then we multiply the inside numbers. 8 times 5x, positive 8 times positive 5x is positive 40x. And then the last numbers. So 8 positive 8 times negative 7 is negative 56. Our last step is to look to see if there's any like terms that can be combined. Remember, like terms have the same variable and the same exponent. So there's no other terms that have an x squared, so that stays as 10x squared. But these both have an x. So negative 14 plus 40 is positive 26 x's. And then your minus 56. Another way you could have thought about this, if the FOIL method confuses you, is to think, okay, first I'm going to multiply 2x by each of these. And then I'm going to multiply 8 by each of these. And then again, combine like terms. The last topic. So now we are going from a problem that's been multiplied out, like this last one we had, and we are going to change it back to a multiplication problem. That's called factoring. So we're taking 4a squared plus 8a and we're factoring it. So on the state test, I'm going to show you a way that you can figure out a factoring problem by using the graphing calculator. All you need to do is eliminate some of the choices because they are not fully factored. So 2 of them at least will probably be able to be eliminated. So if you notice something like this one, 4a squared and 8a, I can divide 4 and 8 both by 4, and they both have at least one a, so that means this is not fully factored. I can divide out a 4a. That's all we need to do. So here, is this fully factored? No, I can divide 3x by 3, and I can divide 12 by 3. So I can factor out a 3. And when I do that, I'm left with an x and a positive 4 when I divide each of these by 3. So all you need to be able to do is identify when something is not fully factored. Is this fully factored? No, because again, 3x plus 12, I can still factor that. How about x minus 5? Is that factored? Yes. So now we have a fully factored problem. So when you're given a question like this, they're giving you a polynomial. They want to know which of these is showing it in its factored form, where if you were to multiply these, like using the FOIL method, you would get this. Now, 2 of these probably, if you multiplied it out, would get you this. But one of them is not fully factored. So it has to satisfy 2 criteria. It has to be the same as this when you multiply it, and it has to be fully factored. So I think the first thing you should do is look at the choices and cross off any that are not fully factored. So if we look at choice A, 3 or x plus 3. Can I divide x by something I can also divide 3 by? Nope. How about 4x and 5? Nope. How about 3x and 6? Yeah, I can divide 3x and 6 both by 3. So this is not fully factored. So the answer cannot be B. How about C? 3x and 5. That's good. 5x and 6. That's good. How about this one? 2x and 6. Yeah, I can divide 2x by 2 and 6 by 2. So this is not fully factored. So this cannot be the choice because it is not fully factored. Once you have eliminated some of the options, all you need to do now is go to the graphing calculator and graph it. So graph this and see what it looks like. Then graph this one and see if it looks exactly the same. See if it lays exactly on that original function you graphed. And if not, graph this one. See if this one lays exactly on the original graph. They have to match. They have to be the same exact graph. If you graph that one, this one has to be right on top of it. So again, you're looking for which of these choices looks exactly like this, and which of the choices is fully factored. All right, guys, that's all I've got. I kept it under 1 hour. I hope you made it to the end. Please rewatch parts that you were confused about. Send me messages, ask me questions, and just give it your all. Study, prepare, and then go do your best on the test. and I'm sure it'll be fine. Good luck, you guys.